Okay, so we continue with another method, which is power method. Okay, so we have two methods, right? So the first one is the polynomial method, and the second one is a power method. So both are to find the eigenvalues and also eigenvectors. But for the polynomial method, we will find out all the eigenvalues. Maksudnya, if your matrices is 2 by 2, so that's mean you should get 2 eigenvalues and also the corresponding eigenvector lah. Maksudnya kalau 2 eigenvalues akan ada 2 eigenvectors. Okay, so if your matrix is 3 by 3, so that's mean you should get 3 eigenvalues and also corresponding eigenvectors. But for power method, we will use power method to find eigenvalues also, but it's just only to find out the largest eigenvalue. Maksudnya kalau for example your matrices is 2 by 2, you do not we use power method, but we just calculate, suppose you should get 2 eigenvalue, right, if the matrix 2 by 2. But for power method, we just find the largest eigenvalue, which is only one. Maksudnya kalau matrix tu 3 by 3 ke 4 by 4 ke, we just calculate together the highest or the largest eigenvalue, which is only one value lah. Okay, clear. Maksudnya kalau power method ni kita cuma dapat satu je eigenvalue dia, which is the largest eigenvalue. Or some textbook or some textbook we use the term of dominant eigenvalue. So dominant means largest eigenvalue. Okay, the largest eigenvalue. Okay, maksudnya macam ni lah. Okay, power method is to find the dominant, or sometimes we use the word, we use largest value, or sometimes we use dominant. So we will use power method to find the largest eigenvalue. Okay, alright. I will show you the steps of the power method itself. So I will show you through the example lah. Okay, senang kot nak nampak lagi pada example. Okay, so example, apply the power method to A. So A is your matrix. Okay, this sizes of matrix is 2 by 2, right? So with the V naught 0, 1. Okay, V naught is a vector, eigenvector. The initial one, okay, is a information that you should have lah, suppose in the question. So the question and then ask you to estimate the dominant. So it use the word dominant. So dominant means largest. Okay, dominant eigenvalue and a corresponding. Okay, maksudnya tu satu je lah kan. Corresponding eigenvector of A accurate to within, okay, error given here is 0.0002. Okay, so this is the example. Okay, this is your matrices, this is your initial vector, and this is your error. Okay, so let's restart how to calculate it. Okay, first thing first, okay, we will let. Okay, actually not we let, it's already given the question. So V naught just now is equal to 0, 1. You should have this one. You should have the starting point. Baru we will proceed dengan calculation. Okay, alright. Okay, so then the next one, AV naught. Okay, your matrix A just now is 6, 1, 5, 2, 0, 1. This is your matrix A, and this is the matrix V naught. Okay, 0, 1 is from V naught just now. And calculate it, multiply these two. So 6, 0, so 1, so it's equal 5, 1, 0, so you become 2. Okay, alright. So this is the matrix of AV naught. Alright, then okay, M naught. So M naught here is represent entry, one of the entry inside here, okay, salah satu entry ataupun salah satu nombor yang ada dalam matrix AV0 ni tadi, we choose the highest value, the highest absolute value. Okay, maksudnya macam ni, highest or the largest absolute value. Okay, absolute means it's a, we consider a positive. Maksudnya kalau sini negatif pun, we just take it, I mean we will assume that one is a positive. Okay, macam ni. Alright, so saya tunjuk dulu M0. So M0 here, like I said, like I write here, is the largest or the highest absolute value that have here, that appear dekat matrix ni lah. So between 2 and 5, which one the highest or the largest one? Which is it obviously 5 lah. So your M0 is 5. Okay, let's say you have a negative 5 here. So between these two numbers, which one is the largest one? The largest or the highest absolute value? Which one? Oh, maybe some of you answer 2. No, not. It's wrong. If your answer is 2, it's wrong because the keyword or the highlight, the main point here is the highest absolute value. Yeah, even though here is negative, but we assume that one is a positive because it's all absolute. Absolute means modulus lah, okay? Modulus. So negative 5, even though it's negative 5, but we consider this one is a positive. So negative 5 and 2, the largest one is negative 5 lah, which is 5. But when we write here, you should bring the negative sign also. Careful memang kita tengok kat sini, kita assume that one is a positive, but when we bring the outside for M0 ke M1 later on, you must bring the negative sign. Kena bawa exactly apa yang kat sini, kena bawa juga. Okay, so this is example. Saya padam balik. So this is example. So your M0 here is 5. Okay, your M0 here is 5. Then the next step is to find out your V1. Okay, how to get your V1? Okay, your V1 here is 1 over M0 times with A V0. Okay, 1 over M0, so 1 over 5. Okay, A V0, we already calculate here. 5, 2. So just multiply this, so we have 1 and 2 over 5. 2 over 5 is equivalent to 0.4 lah. Kalau you nak buat decimal pun boleh, tak masalah. Okay, so the next thing, okay, tadi dah first step. Okay, kita boleh kata ni lah the first step. This one is step 1, this is step 2, identify your M. This is step 3, and then step number 4. Okay, calculate the error. Okay, calculate the error. So I believe that all of you have familiar with this sign, and you facing or you having this in Gauss Seidel. Yeah, Gauss Seidel. So maksudnya kat sini, bila you ada dua modulus sign and also negative, also with the infinity sign, so V1 mana V0. So V1 here means the matrix, the latest one, which is this one. This one is V1, and V0 is this one. Okay, so what we do is you just minus. For example here, this one you must be minus with the same entry lah, same level lah. Maksudnya kalau sini 1, here the location here 1, will minus with this location 0. So 1 minus 0. Okay, saya tulis sini lah, 1 minus 0, and then negative 0.4 minus with 1. So what you get here, 1 and negative 0.6. Okay, but the answer, it must be not in term of matrix, bukan jawapan yang sepatutnya kamu dapat kena satu nilai sahaja. So that's why the infinity here represent. You choose either one, salah satu. Okay, salah satu kat sini. Yang mana satu yang lagi besar? Yes, lagi besar. But make sure kat sini, because of this is error kan, so maksudnya negative 0.6 ni will be considered as positive 0.6 sebab dia error. Error cannot be negative. Okay, so antara 1 dengan 0.6, which one the largest one? Of course lah 1. So the error for V1 minus V0 is 1. So maksudnya satu ni still lagi besar kan daripada soalan bagi 0.0002 kan. So next you need to calculate it, the next one. Okay, so this is the flow lah, kita ada 4 steps. Okay, so until here you see that the error still too far lah from the 0.002. So we will calculate it for the next iteration. So you will start first with step 1 again. So AV1. Okay, now AV1 because V0 dah settle, so now AV1. So matrix A just now sama, matrix yang sama. But now your V1 is the latest one. Okay, 1, 0.4. So you calculate it, multiply these two, 6, 5, 0.2. You will have 8 here. 1, 0.8, so 1.8. So next, find out what is your M1. So what is your M1 here? Okay, your M1 is the largest value that appear in this matrix. So which is 8 lah. Okay, then calculate your V2. What is your V2? 1 over M1. So now it is M1. Tadi M1 over M0 kan? So sekarang 1 over 8 lah. 1 over M1 times with your AV1 here. So you should get 1 over 1 and 1 over 8 divide, 1.8 divided by 8. So I'm using calculator, so you have this one. So then next, step number 4, which is the last one, is V2 minus V1. So same thing, you do it, you take it, the first one, 1, minus what your V1 just now? Oh, V1 just now is 1, okay, 0.225 minus 0.4, okay. So you have 0 here and also 0.2 tolak 0.4. So it's negative, right? Negative, but it's error, so please make sure we ignore the negative sign. Okay, so the highest or the largest value that appear here is 0.175, which is still far lah from 0.02. So you need to do another calculation. So we proceed with AV2. Okay, so we proceed with AV2. Okay, so matrix A is same, sama, tak ada perubahan. But V2 now, so V2 is 0.225. Okay, multiply these two. You have 7.125, 1.450. So means that what is your M2 here? The largest value. So 7.125. Okay, then V3. Okay, what is your V3? 1 over M2. So your M2 here 7.125. Your matrix A2 just now is 7.125, yeah, 1.450. So you will get 1 and then 0.2035. Then the last one, okay, you need to minus. Okay, so 1 minus with your V2 is 1. Okay, 1 minus 1. And then 0.2035 minus with 0.225. So you should get 0.205, 0.225. So 0, negative 0.0215. So that means the highest value that appear here is 0.0215. Okay. Alright, and it's still greater than 0.0002. Okay, kat sini 0.000. 3 kali 0, kat sini ada 1 0. So maksudnya this is still largest than this one. So you need to do it again. Okay, so you can refer to the slide. So I just write the last one, okay? AV5. Okay. Okay, saya skip so it means that you can refer to the slide lah. Okay. So this is AV5. So 0.2001. Okay, so you multiply this, you will have 7.0005 and also 1.4002. So M5 here is 7.0005. Okay, And V6 here is 1 over 7.0005 times with 7.0005, 1.4002. Therefore, you should get 1 over, sorry, not 1 over 1 and 0.2000. So, the error here, okay, 1, okay, V6 minus V5 here, 1, 1, so 0. 0.2000 minus 0.2000, so you should get 0.0001. So the error that I have here is 0, and it's already less than 0.002. Okay, so you can stop it now. Is it? Betul tak? Sama saya cakap kalau dah dapat error tu boleh stop calculation kan? Okay, yes. This is the last step. This is the last calculation that you should do. But at this moment, at this level, you will get your eigenvalue here. Okay, this is your eigenvalue. Sorry, no, eigenvalue. You will get your eigenvector here. Sorry, this is eigenvector. Okay, this is your eigenvector V6. Okay, V6 is your eigenvector, but you need to have another one calculation which is your M6. Dia kena pair lah kan, kalau eigenvalue kena pair lah dengan eigenvector. So kalau you punya V6 dah dapat, so you kena carilah you punya M6. So sekarang kita tak ada M6 lagi, so you need to calculate your M6. So you need to calculate M6, so means that you need to do another calculation which is AV6. Okay, AV6 here. Okay, and then you get the value. Okay, so then therefore you will get your M6 here. Okay, right? So your answer, okay. Actually, you can refer to the slide, but okay, I just write the answer for M6. So M6 here is 7.000. Therefore, case the final answer that you should have here is M6 and V6. So M6 is represent your eigenvalues, and V6 it will represent eigenvector. So M6 just now is equal to 7, and V6 just now is 1 and 0.2. So this is the final answer. Okay, so you can see that we just have only one value. We have only one eigenvalues and also one eigenvector. Maksudnya kat sini this one is the largest lah. Kalau you guna polynomial method, you still get the answer. But polynomial method means that you need to find out both. If the sizes of the matrix is 2 by 2, so that means you need to calculate both lah. Maksudnya akan ada dua eigenvalues. Okay. But for power method, we just find out we just calculate for the dominant or the largest eigenvalues. Okay. So this is all about this chapter. So we have two methods, polynomial and also power method. And like I said before, polynomial is to find all the eigenvalues and also eigenvector. Power method is only to find the dominant or the largest eigenvalues. Okay.